Hello, my name is Emerson, or MTNMCG, and today I will be showing you how to use the Breach engine for Scratch 3.0. At the end of this lesson, you should be able to make your first working game. This video is assuming you have some basic knowledge of the Scratch platform. If you don't, I've left some videos linked in the description that should help you. Let's start off with a basic explanation and history of the Breach engine. Breach is comparable to the Python library Pygame in that it's not necessarily a game engine, but more a collection of systems and functions to make game development a breeze. I have always loved Scratch as a platform to make games off the top of my head, ignoring its limitations and striving for creative, intuitive design. So one day, I had this idea for a game. It was like Escape from Tarkov, but top-down in 2D. I wanted to make this so bad because it seemed fun to me, and like a cool project. I started working on this game, but quickly realized it was going to take possibly years of work to make such a thing in Scratch. I, however, was not put down by this, and instead of continuing with that game, I started working on a game engine that I would slowly upgrade over time and improve until I could easily make that game. Breach is currently 2 years into development, and in its current state is a very useful tool for top-down game creation in Scratch. Let's get into Scratch. Scratch displays everything on the screen. A 480 by 360p rectangle that everything you create shows up on. Most Scratch games keep everything within the domain of this screen, but for what I wanted, this wouldn't work. Instead, I had to create my own screen coordinate rendering system myself and incorporate everything an engine would need within that. Breach's main functionality is within the map sprite. Using a glitch where you set something to a blank costume, then size it immensely, then switch back to a non-blank costume, you can create sprites bigger than what should be possible on Scratch. This is where the levels are made. Instead of moving, the player Breach moves the map around the center of the Scratch's scene to make it appear like there's a larger world around the screen. Then I apply a layer of physics to this movement to make collision. I'm not going to get into the finer details of how the physics works for now, but let's get into the engine. Chapter 1. Movement and Levels. First, let's start with the load level function. This has 5 inputs. First is the level. You put the name of the costume in the map sprite that you want the level to load in here. For example, in Breach 1.3, if you don't change anything, it'll load the level titled Demo. The costume name is also Demo. Then we have the max physics check. I wouldn't touch this too much unless your level has complex geometry, in which case you might have to increase the max checks. Please keep in mind the more checks you have, the slower the game will run. For default, let's set the physics checks to 25. The next input in this function is size. Again, I would leave this at the default, 275. The next 2 inputs are spawn X and spawn Y. This is a pixel offset for where the map will go by default. This does not impact the global coordinate system. 0, 0 globally will always be the center of the map sprite. Next is the move X function. Move X and Y function. This block will simply move accordingly that many steps. It is relative to the map, so to visually move the player up 1, you'd say move down 1. So let's do this. Move 1. We have the player here. Then move. As you can see, the player is moving down by 1. If we do -1, this would be moving up because you're moving it relative to the map. And this works along with the physics engine. Next is the move distance at angle function. This block will simply move however many pixels you define at the angle you define. So let's say move 50 at 90. Move 50 at 35. This also works with the physics engine automatically. Now for the goTo function. This simply puts you at the global coordinates that you specify. So 0, 0 would be the center of the map. At any time, this would work, and you can see all dynamic game objects move along with it. Keep in mind you have to use my global coordinate system because the scratch chords don't work for the engine. Now, let's go into the menu sprite. After playing the game through the menu, that's doing this, it runs a default load level function. That's here. So when the game starts, the menu spawns and then you press a key to continue. Then it'll run this script here. This is what you can customize here. You change the level here, and this will define the costume in here that you're loading. Next is the spawn X and spawn Y variables. These are just like the goTo variable, and they will just put the map wherever you define. This is where the player will spawn when the level is loaded, as you define. You might have noticed two variables under the event trigger. I'm sorry. Then you simply broadcast the load level event. You may have noticed two variables under this event, game and enemies. Game is a fundamental global variable we'll get into shortly, and enemies is a legacy system that you can still use, but I won't be explaining in this tutorial. You don't have to worry about touching it. It doesn't matter. Now, let's say you loaded the first level of your game. You successfully configured the menu sprite and the load level function to your liking. Now you want to go to the next level in your game. There are many ways to do this, like having an if statement and a forever loop saying if x and y is within a certain range, then load level whatever. Another method would be a collision trigger. I have that in my example here. We could have a game object say that whenever it's touched or interact with, etc., you can define it as whatever. Then it'll load a new level. So in here it says, this defines the object spawning. You can look at this later. I'll explain this later. But this is the real meat and potatoes. When this object up here, that's this object, is touching the player hitbox, it'll set game to 0. I'll explain that later. It'll go to set spawn X and spawn Y to 0, so that sets your spawn point to 0, 0. It sets the level you're loading to demo, which is the level we're currently in, and then it broadcasts load level. It looks exactly like this, except for the set game to 0. Because game is already set to 1 when this happens, you have to set game to 0 before doing that as well. I will explain this again later. But now, if you touch that, it'll just load the level again and put you there. Chapter 2, Global Variables. The following variables, game, pause, writing, and do player move, are either set to 1 or 0. They all do very similar things but have unique purposes for your code. You'll have to configure them to align with whatever game system you describe. Game is the most important. This is saying if the actual game is loaded. If set to 0, then only background processes will run, like level management. You would set game to 0, then load a level, then set it to 1 to ensure nothing is processed during the transition. By default, it should set it to 1 when you load the level, but you can customize this in the load level function in the map sprite. It should also be set to 0 if a death event is triggered. This is if you have a game where the player can die. There is a preset death function in here, but you have to define it. It's just blank. I have those events set up just so you can use them. So if the player dies and you want to restart, I would suggest setting game to 0 to ensure that nothing else happens afterwards. Pause is used to stop things. 0 is no pause, 1 is pause. The physics engine also follows this. So, for example, the settings menu, when you open settings, it pauses the game. So as you can see here, the physics engine is paused, player movement is paused, and the settings menu is open. That was the pause function being used. You can set this up to trigger whatever you want. It's just used to pause the game without canceling it. So game being set to 0 it will despawn things. It'll make everything wait until the next level is loaded. Game is like a kill switch if you set it to 0. Pause is used to simply pause processes but allow the game to continue once pause is set back to 1. Do player move and writing are closely related. Do player move being set to 1 means that the default player system in the map sprite will work, but I'm sorry. If do player move is set to 1, then the default walking system will be used. If do player move is set to 0, then the default walking system won't be used. Now, if do player move is set to 0 and riding is set to 1, you'll use the vehicle movement system here. Riding is just to determine whether you're using a vehicle or the default walking system. 0 is default walking system, 1 is vehicle. But in order to use the vehicle riding system, do player move has to be set to 0. You can also use do player move set to 0 for cutscenes. So here, the player is moving, and then let's set do player move to 0. So the player's moving, but now it's set to 0. So the player can't move. I set it back to 1, player moves. Very similar to the pause function, but you can use this for just the player. That way you can determine, like pause will be everything, do player move would be just the player. Has different use cases. Chapter 3, Game Objects. To make an object that stays on the screen and moves with the map and behaves with the physics engine, there are 2 options. There's a legacy system called XOffset, which I'll show you now. Let's make an example sprite. Let's make it not black so you can see it. So now, this will move according to the offset. However, you may notice it's kind of buggy. This is why we use the new system. The other option, and what I recommend, is to have a local myX and myY variable. To do this, you make a variable and choose for this sprite only. That makes it localized. So it's only staying within this sprite. Then you have it in a loop, say global x, go to global x plus my x, global y plus my y. Now it'll always align with the physics engine because global x and global y is the current position of the world. So it'll always be the same, and this is the variable that the physics engine interacts with. So everything that happens will work alongside this. So this here is going to my x. Let's change my x. Let's change my x by 10. Oh, I'm sorry. I had this set here. Forever set my x. There we go. Sorry, it was setting this in a loop. So now we can move this because it's going to that variable plus the world coordinates. Please note, because of Scratch's design, sprites can't go off the screen. To combat this and allow objects to move off the screen, you must use the brush tool. Set to a single pixel. I recommend black because it's hard to see. Set this to 1 pixel and do it on either corner of the sprite. That way, it doesn't register as being off screen. As you'll see here, I'll delete these, and now the object will stay on the screen. But if I have these at the corners, then the object can comfortably move off screen because Scratch has a limit that doesn't allow anything to go off screen. Chapter 4, Vehicles. In the vehicle sprite, there is an event load function. Simply add an if statement under this to define the level you want, then the custom vehicle spawn and other settings you want. So the settings here are costume. So this is setting the costume here. So the first variable in the spawn vehicle is 1. So it sets costume to 1. Then these two variables are the X and Y. So it spawns these globally. These are the global positions that it spawns at. The next variables are angle and color. Angle defines the angle the vehicle spawns at, and color defines a color effect. Because if you have multiple vehicles of the same sprite, then you might want to change their color to differentiate them. It's just a small feature. You can set it to 0 if you don't want to use it. Not a big deal. Please note, when using custom vehicles, you must put the vehicle's costume with the same name into the player hitbox. It'll automatically detect this. It automatically, when writing is set to 1 and you're in a vehicle, it will automatically use this sprite as the hitbox. Just copy and paste it exactly from here into the player hitbox. It'll automatically work. Chapter 5, Particles. In the particle system sprite, simply use your own custom script to determine, or an event. You can use anything you can think of. You just have to trigger this function here. It's really easy to use. Then you set the X position, the global X, and the global Y you want the particles to spawn at. Then you set the costume that you want the particle to be, then however many particles you want. So for example, I spawn this here and it will randomly put a radius of particles there. You can use this for bullet effects, you can use this for blood, you can use this for countless things. It's an infinitely usable particle system. Just simply set a custom costume and customize it with this and set up your own triggers. Chapter 6, the console. When in game, press C to bring up the console. Type help to see the available commands. If you want to add custom commands, you can just go into the backdrop, which is right here under stage. I don't have time to give a complete guide of how the console works. It's pretty self-explanatory, so just go check that out if you feel like you would need that kind of functionality. Now, Chapter 7, Final Thoughts. Now you know everything you need to make a game in Breach Engine. Customize sprites and levels to your liking. It all starts with your first level. You can have things spawn when the level is loaded and have them do custom behaviors. I've left the rest up to you. There's an example game object, that's right here, sprite in the project that should have some relevant scripts you can copy or modify to your liking. If you need inspiration, I've also left some game project files in the description. These use older versions of Breach, so the code might not necessarily be compatible, but you can see how things were done and you can see what kind of games are possible in the engine and how I do certain things. Most of the calls to different functions are around the same, but the physics engine has changed a lot. As well, I've left a link to the Breach Engine Studio on Scratch so you can download the latest version of the Breach Engine when and if I update it again, which I probably will be doing. Thank you for watching.